Good morning, afternoon, and evening, everyone, wherever you are in the world. Welcome to our ChemDraw Connect webinar series. My name is Joanna Janas. I'm a marketing manager at Revity Signals, and I will be your moderator for this session. This ongoing ChemDraw Connect webinar series is an opportunity for you to learn about ChemDraw's features, to effortlessly create eye-catching professional graphics that make your research shine. Today's topic is From Drawing to Discovery, ChemDraw's Advanced Analysis Features. A couple of housekeeping points before we jump in. This session is being recorded and will be available for streaming at revitysignals.com/chemdraw-connect. Please submit your questions through the questions box located in the right-hand side of your screen. Stay tuned for the information about the 2025 ChemDraw Connect series, which will be available on our website. Please remember to re-register for the new 2025 series. We look forward to having you join us in the new year. As always, we want to hear from you. If you have any topic suggestions for our upcoming connects, feel free to reach out to us on signals.events@revity.com. Now I would like to introduce our speaker for today. Paul Stefan Kuhn is a senior field application scientist here at Revity Signal. Paul holds a PhD in chemistry from the University of Vienna and did a postdoctoral research at the University of Gothenburg, where he worked on medicinal chemistry and specifically PROTAC research. In 2018, Paul joined Revity Signals as a field application scientist. In his role, he's focused on helping customers with their digital transformation and on promoting the cloud-native Signals Research Suite and other connected Signals solutions, including Signals ChemDraw. Now I'll hand over to Paul, who will talk you through the topic of today's webinar.
Great. Thanks, Joanna, and thanks everyone for joining today's session. As you'll know, the goal for today is to hopefully show you something new about ChemDraw and refresh some of the existing knowledge. And specifically today, we were focusing on From Drawing to Discovery, ChemDraw's Advanced Analysis Features. So what does that mean in detail? So I will just give you a quick introduction as maybe a reminder into the different ChemDraw offerings types that there are. And then we will jump directly into the live session. And we will focus today on the one hand side on the structure generation. So how can I quickly generate structures, drawing by hand, but especially getting them from like cast numbers, names, etc. That could be single structures, that could also be libraries of structures. And then we spend, I would say, even more time on the different functionality that you have in ChemDraw to analyze your structure. That could be property calculation. So we will look at kind of different types of properties that you can calculate, the different places where you can do that within the ChemDraw suite. We will look at the NMR predictions, different options to create 3D representations of your structures, including also some coloring options. And then we will wrap it up with some of the bulk actions that you can perform in ChemDraw for Excel. That could be bulk actions like calculations or predictions on the list of compounds, as well as some sort of like combinatorial chemistry, both as I've done within ChemDraw for Excel. So this is, you can see just as a refresher, I guess for most of you, that we have released Signals ChemDraw earlier this year, and this is kind of the first time that ChemDraw is integrated within the Signals platform. Besides that, there's still the ChemDraw Professional, the ChemDraw Prime available as it used to be. So what does it mean that it's integrated within the Signals platform? Of course, it still comes with the most rich ChemDraw desktop, what was formerly known as ChemOffice. And then we have expanded that with these integrations, and they give you a few benefits. And one of this is, of course, the access to ChemDraw products via the Signals platform. You can very easily manage your licenses in user as part of the Signals configuration, and activation will also happen via authentication against that platform. So there's no activation codes needed any longer for Signals ChemDraw. In addition, So that we have these integrations with the desktop application and the cloud native Signals platform. I will talk a bit about that today, and also automatic updates for one of the new apps that has been added to it, which is called ChemDraw Plus. And that's basically, the cloud native option to draw your structures and share, of course, that information as well, which is also part of Signals ChemDraw. Besides that, there's also a couple of other applications that I just want to highlight today, which is called ChemDraw Collections, and then also a Hell monomer curation option specifically for ChemDraw Plus. That being said, let's directly jump into the live application, as we have, I think, a very packed, very full agenda of topics for the next roughly 45 minutes before we come to some of your questions. And so even though the focus for today's session is really on the structured analysis, so the different features that Signals ChemDraw, so ChemDraw Professional, give you in that regard, I still wanted to start with a kind of a bit of a recap, a refresher on how can I quickly draw structures from scratch, because I think this is, from my personal view, the one feature that I would always recommend people getting into, as long as you have to draw really structures from scratch and do this on a regular basis. So I picked like a couple of examples here of kind of newly approved drugs, and I just want to show you, maybe just on that one example up here, how you can quickly recreate their structure if you have to draw it, before we look at some other options to get in structures if you either have already like a name or a cast number at hand, or are maybe not that proficient in the kind of the drawing. So let's just start. And by the way, what I press on my keyboard, you will also see down here on the left-hand side, to make it a bit easier maybe to follow here. So I will start with just also activating the tools that we have here on the left-hand side with my keyboard. So I press an X to get the single bond. I start with the first one, and then I move away my cursor, and I will just basically start typing here. So an O, a 1, an A for the aromatic ring, fluorine. I will use the kind of my keyboard arrows to navigate, and thereby, as you can, let's go back one step. Let's really reproduce it. And then, as we can see, in literally like no time, we have recreated that structure. And of course, this is not something that, I guess you learned from watching this one webinar. So there's certainly a bit of a training that will help to get closer to kind of a high speed, to save a lot of time. And what I want to point out here today is really there is, of course, help in ChemDraw. So if you navigate to help and the hotkeys cheat sheet, that's the place where you can like get a nice summary of all the available hotkeys in the system that you can either use for drawing, as you can see, atoms and also bonds, of course, and then also some of the additional actions like creating reactions, rotations, and so on. You can print it; it nicely fits on an A4 page. So I said that just as a bit of a reminder, because I personally think this can save you really a lot of time whenever you have to draw structures. Instead of doing the point and click, use these hotkeys. With that, let's come to some other ways how I can actually use the advanced features in ChemDraw to generate structures in a very easy, reliable fashion without having to draw them. And as I guess most of you know, there are quite some different options available in ChemDraw. You could use a cast number, you could use a name, both to generate like full structures. We have the concept of nicknames that allow you to give like a name to a part of a structure, like, I don't know, a capping group or a protective group, but also, of course, linkers, and can then use these nicknames to bring back these parts of structures very quickly. Of course, you could use templates or synonyms, etc. as well. So let's look at a few of those options here. One that I think most of you are familiar with, is a very established one, is the name to structure function. And I have already a name here. So the way you can access that is either navigate into the structure menu, convert the structure to name. You could also use the structure menu that I put up here in my toolbar, but already from the initial few minutes, you might have figured that I also personally like to use keyboard combinations quite a bit. So also here, there's a keyboard combinations available, which is Control-Shift-N. So you could either highlight the name if you have it already somewhere and then press Control-Shift-N like I do now, which will directly give you the corresponding structure, assuming it is available in the underlying list. If it's not, it will also check against the ChemASX library, which is the library that we put together where we like consolidate commercially available information. And we will use that ChemASX library also for the cast to structure conversion. And of course, you could also use a synonym, etc., to get to the structure, for example. So if you don't have a name selected yet, you would just press Control-Shift-N. It would bring up a dialog. You would type in the name and then again get the corresponding structure. So that's one way to quickly get to full structures from a name. And maybe it's a good time also to highlight here that you can also go beyond that and add your own structures to the dictionary. So the next time you maybe have an intermediate, a very special structure that is not yet in this central repository, you can draw it one more time and you can add that structure to the dictionary, give it a name, and then retrieve it the next time from that name. Another way, as I just mentioned a minute ago, is to use one of the add-ins, and we will look at quite some of different add-ins today. And the one I'm using now is the option to get from a cast number to the structure. So the only thing you have to do is basically type in the cast number, press search, and then it will first of all check if that is a valid cast number. If yes, it will look in this ChemASX library and usually, if it's available in there. If yes, it will return the structure. And that's, again, a very easy, reliable way to get from a sort of identifier to the structure. If you don't have the cast number at hand, but maybe some synonym or maybe a catalog number, etc., from a certain vendor, you could also use the ChemASX Explorer, which is, again, using the same underlying database, but basically gives you more options in terms of the input value. And as I mentioned before, this is a database of commercially available compounds where we have consolidated information from a large variety of different commercial vendors. So these are two easy and quick ways to get from some sort of identifier like a name or a cast number, synonym, etc., to the structure of the full molecule. There are, of course, also many cases where say, oh, I just want to kind of bring in a part of a molecule, which could be either a protecting group, capping group, those things, could be linkers, any part, in no time. So how do I do this? So in ChemDraw, we have the concept of a nickname. So if you go to the file and then list nicknames, you will already find a long list, very extensive list of nicknames and structure pairs that the system understands out of the box. And again, you can add to this list, like you could also do with a name to structure. And the way you do this basically is that you define your, in this case, protective group, and you add the connection point, and you do this by pressing the dot or full stop symbol on your keyboard. You select this, and again, you go to structure and define a nickname. So you give that a nickname, and then the next time you draw the structure, and pressing here X, N, 1, enter for the text tool, TR, it will actually understand this, and you can use the expand label function to get to the full underlying structure. But of course, even before, like when we had the label still in there, right? The system fully chemically interprets, of course, that label, meaning that you can go, for example, to the analysis window, which will then give you the formula, the mass, some master charge ratios, elemental analysis, so really basic analytical information of what I've drawn here. And that's already one, as an initial way how you can get some analysis information of your structures. If need be, you can also always paste those into your ChemDraw canvas. And of course, that's not the only analysis option we have. We will look a bit later at NMR, different ways to predict properties, as already said during the introduction. So what have we looked at so far? If you need to get in a structure, you can either draw them. So I would recommend the hotkeys, which really can save you a lot of time, especially over the course of, if you think over the course of a year. But there are also other ways, like getting a structure from the cast number, from a synonym, from the name, and then also doing this for like either full structures or for parts of the structures. And in both cases, with the nicknames and the name, you can enrich the out-of-the-box lists by either defining a nickname or adding a structure to the dictionary if you want to use the name to structure functionality here. If we do not only want to get in one structure, but actually rather create a library of related structures, ChemDraw comes with the concept of generic structures. In more detail, the system understands different variables that you can define, and I have already prepared in this example most of the different options that exist. So the first one is shown down here in the square brackets, where you can literally just type a comma-separated list of atoms. And then it will interpret this, either I have a nitrogen, oxygen, or sulfur sitting at this position. Another option is to define a range that could either happen using the parentheses like I've done here, or if you more have like an oligomeric or polymeric structure, you could also define it there when you use these type of brackets here. The third option that you then have is that you can select certain positions, for example, at a ring, but in general, certain positions where a substituent could sit. And you do this in the normal fashion, but just holding Shift and selecting those positions. And then you would go ahead and add a variable attachment. And when you do this, this kind of star symbol here will appear, which allows you to then draw your substituent. And when we will do the the expansion to the full library in a second, you will see that the substituent will either sit here, here, or that position. And I guess the most powerful one, maybe also the most known one, is then that you can define also residues, so R groups. And the way you do this is that you give them a name, and that you also then use later on the name here in that table. And you don't have to call it like R, R1, etc., but it's important that you give them kind of the same label, same name. The table can be found here in the query tools. And again, in here, you define your different residues. You use this full stop symbol like we already had before when we talked about nicknames to indicate that's actually the connection point. So ChemDraw knows that, this position here will be connected with my amide nitrogen position. And then you select your entire generic molecule, and you go ahead and navigate to structure and expand generic structure. And here you have two options. You can expand to get the full set of structures that are represented by this generic structure within ChemDraw, and that works up to 200 structures, or you can directly expand to an SD file to have that as a separate file that you can then use in other applications. Of course, you can also combine this with different coloring options that we will look at in a moment, for example. So if we move ahead and expand, so that we can quickly generate a large set of related, but still slightly different structures based on the different variables that we had defined here. And in this demo scenario, we varied the heteroatom, we varied kind of the ring size over here, we varied the position of this substituent as well as our residue over here. So in summary, it's a very quick, efficient way to create a large set of related structures by defining just one generic structure. And of course, those, or at least quite some of these variables are also understood by, for example, Reaxys or SciFinder. And if we navigate a bit back to one of the structures we had created earlier, let's quickly look at the options that we have as part of the ChemDraw offering to quickly search for like literature of those, because that's of course always important when you do analysis as well. So if we, for example, take ibrutinib over here, ChemDraw has an integration with Reaxys as well as SciFinder, and that means that you can either quickly draw the structures you want to search for or reuse already existing drawings, and then either navigate to the search over here or simply use the tools in my toolbar, for example, the search in Reaxys. And in both cases, you can either perform a substructure or exact structure search, but of course you can also go beyond the structure searching by adding, in case of Reaxys, an arrow to perform then a product search. If you would use the SciFinder integration, you wouldn't even need the arrow, but the dialog would give you all options together. And I can quickly say, oh, I want to run an exact structure search over here, which will kind of submit my search query to either Reaxys or SciFinder. Of course, this requires like a Reaxys or SciFinder license in addition. And you get direct access from your drawing to the search results, either in Reaxys or SciFinder. And then again, as you're used to, you can navigate to literature. You can get access to physical data, and et cetera, from here. If we want to use the ChemDraw native property calculations and in general analysis features, as I said before, there are multiple places where we have where we can calculate properties. We already looked at the basic analysis window to get access to molecular mass, mental analysis, composition, etc. So let's look at some additional items that exist here. There are actually 3 places where you can calculate additional properties. One is within the ChemDraw desktop canvas that we see over here, where I could, for example, use the chemical properties window to get access to some items like a log-P, TPSA, C-log-P, and so on. And then there are additional options for certain properties as part of the ChemDraw for Excel, as well as part of Chem3D. And if you need to get like a full overview of the available properties, you can always navigate to the help file and search in there for property calculation. It contains a full set of, like a full summary of the available properties. But of course, when we get to Chem3D and ChemDraw for Excel in today's session, we will also look at some of the available examples in life. Besides, if we stick to, or if we stay in here in the main ChemDraw application for a little bit longer, besides the calculated properties, you have of course also access to predicted NMRs that can be proton NMR or carbon NMR. The way to get access to those is you select a structure, you either navigate then to structure, predict NMR, so proton carbon NMR shifts, or again use the structure toolbar here, and then just click on the respective symbol, get the calculated predicted NMR, some explanation of how those calculations have been performed. And just a quick addition here, if you navigate to the preferences, there's also a dedicated section in the settings. Let's try that one more time. Where you can, define certain items like which solvent should be used for the predictions, etc. Sorry for that. Get back some of the structures we had, so we can talk a bit more about different options. So as I said, in ChemDraw here, you can start from very basic analysis options like molecular mass, like some of the properties like log-P, TPSA, etc. You have access to NMR, for example. And in a few moments, we will also look at these other places in Chem3D as well as in ChemDraw for Excel, where you can calculate additional properties. Before we go there, I just wanted to talk a bit about the different options that you have in ChemDraw to get to 3D representations of your molecule. And again, there are different levels of 3D representations accessible in ChemDraw, depending on, in the end, on your specific needs, right? In some cases, it might be sufficient to have what I would call like a pseudo 3D representation of your structure, in contrast to this, right, to this flat one. I mean, every chemist, of course, understands or has an understanding of the 3D view of this based on that drawing. Let me, for the moment, also remove the coloring here again. But there are a few quick ways in ChemDraw how to get from this, so in the end, flat structure to a more meaningful 3-dimensional representation. And one of the different options that you have available is what we would call the 3D cleanup in here. So either you use it via the structure menu. Again, if you would have the structure toolbar available, it is also accessible via that option over here. And whenever you activate that, it will perform, let's say, 10 basic optimization cycles. So depending on kind of the structure, you might want to run this multiple times. Within a few clicks, we get from kind of the formerly flat structure to something that is, say, much closer, of course, to reality in terms of the actual 3D structure of this molecule. And as you can see, it's using the in-depth shading. So everything that's to the back, basically, it's shown in gray, more to the front is in black. So that is kind of the quickest way to get to some sort of 3D view of your molecule. You have another option in here, and that is you can use the Chem3D hotlink window to get, again, a more, in this case, the ball and stick model of your drawn structure. If you then need to run maybe some advanced optimizations or do some other predictions, calculations, surface calculations, or need to measure certain distances, etc., you have then the option from here also to launch Chem3D, or to launch actually that molecule in Chem3D, right? And in here, just as a quick intro today, that you can run certain calculations that could be energy optimizations. You can calculate different types of surfaces. You can also go ahead and calculate, for example, distances between certain atoms in your molecule, right? And also, besides that, go beyond that and calculate also here a large set of different properties, right? And these could again be things like we saw before, like log-P, etc., but they can also go way beyond that. So this is the second option that you have as part of the wider Signals ChemDraw suite of products in the end, to get to certain calculated properties in the end to analyze your molecule further. If we navigate quickly back, there's a last item in ChemDraw that also again gives you access to another type of 3D representation for, or let's say for another use case, and that is the one-click access to your structure as a ball and stick model in the 3MF file format. And this file format can then, for example, be reused as part of a presentation. And then it's not just understood by, in this case, PowerPoint I'm using here, but you can also use it as part of animations to incorporate it in any presentations, for example. So depending on the underlying use case, you have different options to get access to 3D representations. And again, the key here is in a very easy fashion. So if it's just about getting a first feeling for the 3D representation of the structure, you can use the 3D cleanup. Keep in mind, it runs 10 optimizations with one click, so you might have to perform that action several times. You can use the Chem3D hotlink window as well to get an initial access to the ball and stick model. If you need to perform more extensive optimizations, additional property calculations, distance measurements, and other special calculations, you can always transition from here to the Chem3D or to the full Chem3D application, which is part of the suite of products. And finally, you also have access to the 3MF or copy as 3MF action, which allows you to get a quick access to a ball and stick model that you can incorporate into your presentations. And of course, especially this 3MF model will also include certain coloring options that you might apply to your molecule. And again, there are different coloring options that come with ChemDraw. Some of them are already very established, like you can color by atom, you can color, or by element, I should say, you can color bonds. And more recently, 2 additional options have been added, which is either the option to kind of fill certain rings with color or highlight, which I think can be very useful, for example, when you need to highlight part of your molecule that you need to talk about as part of a presentation, as part of a report. So that makes that much easier to use the structure as part of your communication. And the way you would do this is you would bring up the highlights color toolbar, select the color, apply it, and if we copy this one now as a ball and stick model, it would include that as well. Let me share that again, like in this representation. So to make this even more powerful as part of your presentations, for example. Let's quickly summarize again before we move on to the next topic. So we started off with a quick recap of how can I draw or get in structures. Again, in the most efficient way. That could be using the hotkeys if you need to draw from scratch. That could be from a cast number, from a nickname, from a name, from a synonym, etc. if you don't even want to draw the structure, but want to use the different available sources. You could also generate libraries using different types of generic structures, and you could either create them within ChemDraw or also directly create an SD file that you can then use in other applications. And in fact, we will use one of those files in a moment when we look at the bulk actions you can perform in ChemDraw for Excel. When it comes to analyzing structures, we already talked about some of the different places where you can calculate properties, which could be as basic as the mass, elemental composition, a bit more advanced like a log P or a TPSA, and that can both happen via the analysis or the chemical properties window in here, or set in a bit more advanced fashion also in Chem3D to use the more extensive options you have in there to run certain property calculations. You can predict NMRs in there, so there's some basic settings in the preferences also affecting then those NMR predictions. And of course, you can also transform the structures as we just looked at the end to get 3D representations for the different use cases, either in here with the 3D cleanup, in Chem3D, where you can then also run extensive optimizations, distance measurements, etc., or as a 3MF format to, for example, incorporate in your presentations. With that, let's move on to the third component I wanted to address today, which is the capabilities you have available in ChemDraw for Excel. And here I want to specifically highlight 2 different aspects. One is around bulk options that you can perform on a list of structures in the end. And the other one is combinatory chemistry. So how can I use this functionality in ChemDraw for Excel to generate me combinations of product from lists of starting materials? And what can I do further with those created reactions. Let's start with the bulk actions that you can perform. And in ChemDraw for Excel, first of all, you have different options to get in your list of molecules and potentially already associated data. One way is you could import tables, for example, from an SD file, as I will do in a moment. You could also, of course, draw those by just double-clicking in the cell, adding them one by one, or copy and paste them in. But you also have the option, for example, if I just quickly type in a name here, to convert certain information, like a name or an inch code or smiles, to the respective structure. And as you're in Excel, as we talk about bulk actions, that can, of course, be done in bulk on the entire column. In our case, let's remove this and actually import the table. So this is a list of these 81 structures that I generated before from the generic structure that I had drawn in ChemDraw. So see, we can bring those in bulk. And what has now been added with this plugin is the option to have chemistry-specific calculations of functions in here. And again, so that's the third place where you can, by using these functions, predict certain properties, generate additional information, so enrich your kind of list of structures with simple information like the name or the SMILES code, the composition or the formula, but you can also go beyond that and predict certain properties like boiling point, log P again, and so on and so on. And as we're in Excel, this is an Excel plugin, you can not only do this kind of for one cell, right? Let me just maybe create the formula, right? And not just do this for one cell, but of course we could do this if we want to for selected cells or for the entire column. And thereby you can quickly enrich your data set if it's just kind of a list of structures with additional calculated properties. And of course, use then also that plugin to maybe add measures to actual results to this as well, to quickly get to a very comprehensive set of information, including structure and textual or numerical data. So in summary, this is the place where you can bring in lists of structures to calculate, as we just said, enrich that data, but where you can also generate structures in bulk if you only have identifiers like the name, SMARTS, or inch code at hand. You can always then export these again in different file formats to be used in other applications. The second topic I would like to address today with regards to ChemDraw for Excel is actually the CombiCan option that comes with that plugin. So the way it starts is that you basically activate the reactions, which allows you to to bring in your generic reaction. So let's just double click on this one here, and then basically move ahead and define our reactants. So what I've defined here is that I basically want a couple acids and amines. So I defined where are kind of the positions I vary by calling them R1, R2, R3. And then, of course, importantly, using the same identifiers also in my product. As a next step, I now need to define my different reactants. So my list of acids and my list of amines. And again, you can do this one by one. If you just double click on that field, draw the structure, indicate if this should be used for this specific enumeration or not. But you can also bring them in directly from a file, or if you're still using ChemFinder, also from there. So there's a file I prepared. Let's bring this one in. I have a set of acids. I do the same also for my sets of amines. And I said before, you need to define at least the structure and indicate if the system should use this specific reactant as part of this enumeration. If you're happy, if you have defined all your different variables that should be used, you can go ahead and create kind of your first experiment, and the system will tell you, oh, you have defined 3 amines, 4 acid. That allows me to create like of 12 products. If you agree, the system will go ahead, create, do the enumeration, create this specific experiment with the different products for you. And with that in hand, you can then go ahead, right? For example, assign, if you do this in a plate-based fashion, assign the different reactions that you have just created by the enumeration to welds. You can then create a plate worksheet where basically, oh, this is how the reactions could be plated on the standard plate, etc., etc. And of course, again, you could use that information, extract it, move it to other places. So in summary, ChemDraw for Excel does not only allow you to perform the bulk actions that we looked at before, which could be identifiers or like name to structure or smiles to structure conversions in bulk, as well as calculations of quite a large range of different properties, and then extract that, for example, to an SD file. It allows you as well to enumerate, create certain list of products from given sets of starting materials, assign those or put those in welds, put them on plates in the end, extract this information to be used or to be directly conducted in the lab. That being said, let's, I would say, quickly summarize all the different options that we looked at today and then transition over, use the last 10-15 minutes to look at the questions that came in and answer most of those. So in summary, we looked at quite a wide range of different functionality options that come with a ChemDraw suite of products. Not only with regards to, sorry, let me bring back the other one as well. Not only with regards to quickly drawing with the hotkeys, like I've shown you on that example, or bringing in structures from certain identifiers, which can certainly save you a lot of time, but also, or especially today, with regards to analyzing the structures, calculating properties, which you could either do in here, in Chem3D, in ChemDraw for Excel, do this as well in bulk, especially in Chem3D, generate 3D views of your structures to then be used for different use cases. For example, as part of your presentations, make it easier to use the structure as a way to communicate by including colorings as well, which could be highlight colors, which could be ring fill colors, or kind of the more traditional color by element options. Of course, not to forget about things like NMR predictions. Again, as a quick way to get some initial insight into, oh, is this really maybe my product that I've just synthesized by comparing your measured and the predicted NMR. We then also looked at the CombiChem options to generate list of reactions, experiments in a quick way, as well as the generic structure options to generate libraries of compounds to then be used in other places. Of course, there's like quite a lot of additional functionality available in ChemDraw. For example, access to safety information, access to Google Scholar, Google Patterns, so similar search as we looked at with regards to the Reaxys SciFinder. It would bring up a tooltip you can search by smiles or by any by some other information, for example. And maybe as a last information, something that I also showed you in the beginning in my intro slides. With the latest release, with the integration into the Cygnus platform, you also now have the options to not only use ChemDraw locally, but also use this additional app, ChemDraw Plus, to basically access your drawing, edit the drawing also from other places, store them centrally. And so there are initial integrations from here with the Cygnus platform, for example, to get directly to the ChemDraw Plus, but also when it comes to the saving, you have the options like to save things to directly to Cygnus, for example, instead of just saving it locally and just have it at that one computer. That just again is a bit of additional information. And with that, say let's look at the questions that came in. So one is around the options to access chemical drawings from other devices where I don't have ChemDraw Desktop installed. And I guess it's a great question. I guess that was asked before I kind of mentioned it again in the end, these initial integrations with ChemDraw Plus and the wider Cygnus platform, because that's exactly what this allows you to do. You can, for example, let's assume you have drawn a structure on a machine where you have ChemDraw installed locally. You could use this Save to Cygnus option. You would put it kind of in this central cloud native repository. And then you could use other devices where you don't have ChemDraw Desktop installed, but directly access the ChemDraw Plus via the browser and get access to your drawing in there, have the ability to modify it, and of course also to share it. So that is absolutely possible. There are quite some questions I see around Helm, and that is so definitely thanks for those questions. That is something that I haven't addressed in today's webinar. So let's maybe quickly talk about this. And the questions I'm referring to here is there a way to share Helm libraries with colleagues? What's the difference between defining a nickname and a Helm monomer? So absolutely, let's look a bit at that, those two specifically, and talk a bit about Helm. So before I address the question specifically, maybe just a few words about what is Helm in ChemDraw, or what is Helm in general. And Helm stands for the hierarchical editing language of macromolecules, and it basically allows you to define certain monomers, give them names, and then quickly generate oligomeric, short polymeric structures from these. And the way this can be done in ChemDraw is that that you use this Helm editor, which you access via kind of the View Helm monomer toolbar, and by default it comes with certain libraries and also certain categories. So you see there's something for peptides, something for oligonucleotides, I would say general chemical items. And so each of these have certain out-of-the-box libraries, like the natural monomers, like amino acids over here, Cygnus monomers. But you can also add kind of your own monomers, your own custom monomers to it. And then the way this would work is that I, as kind of the scientist, I would just pick certain, and sorry for the overlap, certain monomers, kind of one after the other, and thereby quickly generate this oligomeric structure. And of course, these monomers are fully chemically understood. I can expand the structure like I did before with the nicknames. Thereby quickly generate these larger structures. I already mentioned that I can manage my own monomers, so I could go in here, move to the user library, add my own custom monomers to it, and as part of Cygnus ChemDraw, there's also a way then to share the libraries, to make libraries available to your entire organization. So that's definitely a possibility. And when it comes to the difference between a nickname and a Helm monomer, I would say a monomer in here is much more flexible in a way that you can use it as part of these, I would say, larger sequences, whereas when I have a monomer, I have this defined as part of just my specific structure, but I can't kind of connect several ones to each other. So I hope that that answered that question. They are definitely related, similar, but with the Helm monomers, so you have additional options to kind of create oligomeric structures out of those. Oh, so could you please repeat how you pasted the structure in PowerPoint? Absolutely. So what I used here is a functionality, again, available in Cygnus ChemDraw, whereby I select a structure and then I use this copy as 3MF option. That creates this ball and stick model. I will have it in my clipboard, and then I directly paste it into the PowerPoint, just Control V to get then, in this case, that structure in here. And this then allows you as well also to add animations, etc. to it. There's another question, where again to find the NMR function, in which taskbar is this? So that is part of the structure toolbar. Once you've activated this is the one I have over here. You will see there the kind of the proton and carbon NMR prediction buttons. If you don't have that displayed, you can always navigate to structure and then predict proton or carbon NMR over here. There's another question around Helm, I think that just came in, if that could also be used for metal organic frameworks. Honest answer, I don't know. I have never tried that myself, so it would be great if you could maybe share an example offline of that, or of the specific MOF that you would like to create, and I'm happy to look a bit into this. I think those are all the questions that came in today's session that I can answer right here. There are a few additional ones where we will definitely connect offline to give you the best answer to that.
That's perfect. Thank you so much, Paul. This has been a great session. I'm realizing we're coming to the top of the hour. So might be running out of time to cover any more topics here. Is there anything else you want to finish with?
Maybe just, I just saw there came additional 2 questions in. Let me just use the last 1 or 2 minutes to address those as well.
Sure.
And then definitely wrap up and thank everyone. So there was one question that was a bit related to what we had before with the generic structure that was about drawing a polymer. And this is another option how you could quickly generate like longer or polymeric, in this case, structures with the brackets. So what you would use here is this kind of square-like brackets that you can add around whatever repetition unit you have in your polymer. And that by default, it will allow you to add a label, a repeat count, like, I don't know, I have 300, 500 or so repetition units of that, or range, maybe you have, I don't know, 20 to 40 if it's a more oligomeric structure. You can also use the right click to define an average molecular weight of whatever you've drawn in between here. So you say, okay, this is roughly 40,000 grams per mole. What is, again, in polymer of that repetition unit. So what I've actually seen quite often being used here is a combination of these brackets and then the Helm capability, where customers from that space have created their own building blocks. So basically, they took the different like monomers of the polymer, created them as new Helm monomers, and then quickly generated maybe the polymer, if it's a polymer consisting of more than one building block, and then combine this with these square brackets to indicate also the rough average molecular mass of each building block. So I said it's either defining average molecular weight. You also have the option to define a range, a specific number of the repeat count, or more in general, indicating what sort of type of polymer it is that you have drawn. And then maybe the final one before I wrap up is if I could comment on the help menu, and I will give you general answers, so please add then if that didn't cover what you were looking for. So in the help menu, you basically combine all the different types of help that come with ChemDraw, right? First of all, and I personally use that quite a lot, is the help menu or the help file. It's a very extensive file where more or less everything that exists in ChemDraw is described. And so I mentioned that already earlier when it comes to all the different types of analytical properties that you can calculate. Besides that, so there's always good to look at the recent editions, which is kind of what's new for ChemDraw. And there's also, of course, the place which I would highly recommend to everyone that's not using it yet. This summary, so the cheat sheet for the hotkeys. This was useful for the drawing molecule structures by hand, and then also kind of all different shortcuts. So this is like additional keyboard combinations that exist, again, that you can use to save some time. And with that, I would thank you all again for joining today's session. I know there's still a few outstanding questions that we'll make sure to get back to offline. I hope you enjoyed it. I hope you all learned something new about the features that come with the ChemDraw suite of products to analyze your structures, but of course also to generate new structures, to do certain actions in bulk, to use the structures as part of your communication, presentations, etc. So thanks again, and I hope to see you all again in the first session of the 2025 series. Have a good day, everyone. Bye-bye.